Okay, in this video, I'm going to talk about how do you identify a quadratic function. And if you're looking at a function, whether in its equation, a graph, or a table, how do you know for sure that it's quadratic? So just a reminder, this is standard form, ax squared plus bx plus c equals y. Remember, a cannot be 0, because if a is 0, then there is no x squared term, and that is not going to be quadratic anymore. It would be linear. So as long as an equation can be written in this form, it is quadratic. So it must have an x squared term, okay? Not x cubed, not x to the fourth, not x to the 1/2. It needs to have an x squared term. So let me just show you some different ways you might see this. So here's an example, y equals -2 parentheses x plus 5 squared minus 3. Just FYI, that is in what is called vertex form, which I'll talk more about in another video as well. So let's rewrite this so that it is in standard form. So what I'm going to do first is I'm going to square the x plus 5, which looks like this, x plus 5 times x plus 5, which is x squared plus 5x plus 5x plus 25. Remember, using the area model, x times 5, 5 times x, and 5 times 5. All right, so now that all of that is being multiplied by -2 and then subtracted by 3. So I need to combine these two terms. So I'm going to rewrite this as -2 times x squared plus 10x plus 25. So now I'm going to distribute the -2 to all three of those terms, which gives me -2x squared minus 20x minus 50, and then my minus 3 is in the back. Notice that I did not multiply the -2 times the -3. The -2 only gets multiplied by what's in parentheses. So now I need to combine these two like terms because they are both constants. So my answer is -2x squared minus 20x minus 53. So that is now standard form. A is -2, B is -20, and C is -53. So that's in standard form, so that is good. Now, am I saying that you have to rewrite this every time? No. I just want to show you how it can be rewritten in standard form. So if you see something that looks like that, the original example, you know that that's quadratic. Now this is in factored form, which we have seen before because we have factored. And so you should know that when you multiply this, you are going to get a polynomial that has a squared term. So let me just quickly remind you how I'm going to set this up. X plus 4. So 2x squared minus 2x plus 8x minus 4. These are your like terms. So this will be written as 2x squared, -2 plus 8 is 6x, minus 4 equals y. So again, that can be written in standard form, so it is a quadratic. So three kind of different ways you might see it. You might see it in standard form, you might see it in vertex form, or you might see it in factored form. All three of those are fair game. They're all quadratics. When you're looking at a graph, a quadratic function will be a parabola. Just really simple, a U shape, more like curved, not, okay, it can be open up or it can be open down. We are not going to be working with these, okay, so that's not something that we're going to be looking at. Now, this is the one I really want to focus on. To determine if a function is quadratic from a table, you need to look at the second difference. So I'm going to show you what I mean by this. Okay, so remember, in a linear function, the rate of change needs to be constant. Okay, so remember, we find the rate of change by finding the change in y over the change in x. Now, the change in x here is all +1, so that's nice. Okay, let's look at the change in y. 11 to 5 is -6. 5 to 1 is -4. 1 to -1 is -2. And -1 to -1, that's plus or minus, doesn't really matter, 0. So this is not linear. It does not have a constant rate of change. Now, the second difference I was talking about is this. The difference from -6 to -4 is +2. The difference from -4 to -2 is +2. And the difference from -2 to 0 is +2. That is the second difference that I was talking about. Okay, that is your second difference. Because the second difference is constant, then it is a quadratic function. Here's another example. Table's written a little differently. So again, the change in x, is all +1, so that's good. Now I need to look at my change in y. 5 to 4 is -1. 4 to 1 is -3. 1 to -4 is -5. And -4 to -11 is -7. And so now I need to find the second difference. Use the same color. That's a -2, -2, -2. So because this second difference is constant, this is a quadratic function. So to determine if it's quadratic from a table, you need to find the second difference, and the second difference needs to be constant. If it's not, then it's not quadratic.